Good day everyone. Hi, my name is John Erickson Siroa from DSIE 1D and my course is all about Computer Science Information Technology. And I choose this topic titled Combinatorics because I feel comfortable and easy to discuss. And I hope my presentation will good for all audience and either to my instructor. Before we start discussing combinatorics, I want to share with you is to intend learners to develop their computing skills in discrete mathematics, in particular combinatorics, and also to enhance students' ability to solve practical problems using mathematical concepts. And lastly, your objective is define or want to know what is combinatorics, and also is what is the role of combinatorics in computer science, or rather to familiarize the role of combinatorics in computer science. And now, let's start our discussion in combinatorics. When we say combinatorics, the word combinatorics, according to the Britannica, it may also called as combinatorial mathematics. Combinatorial mathematics, which field of mathematics is primarily concerned with problem of selection, arrangement, and discrete system. And also, combinatorics is an area of mathematics, which primarily concerned with counting, both as a means and an effort of obtaining results. Obtaining results and certain properties of finite structure. And also, combinatorics is a development of computer technology in the second half of 20th century. That is a main cause of interest in general and combinatorial theory in particular. And also, combinatorics is not only arise in numerical analysis, but also in design in computer system and application of computers to such as problem like information storage, and retrieval. And let's move on to another topic, or discussion rather. Hey guys, did you know what is the mark is this? If your answer is exclamation point or mark, or rather exclamatory point or mark, you are correct. In English subject, we use this to indicate or express our strong feelings, strong emotion, and or to show emphasis. But in discrete math, we use this exclamation point to be used into the whole product of positive integers to the positive integers. And denoted by that integer, we call exclamation point, and that's what we call factorial. Okay, factorial. And now let's take an example of simple factorial. 7 exclamation point, but we can read as 7 factorial. 7 factorial. And how we solve 7 factorial? So easy. Just write 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And so we need to answer this. So the answer is 5,040. The evidence is try to calculate this in your calculator, and that's the answer of 7 factorial. Another example is 3 factorial is equal to 3 times 2 times 1 is equals to 6. 3 factorial is equal to 6. In simplest form, factorial function says is to multiply the whole number of the chosen number with to 1. In more mathematical term, factorial function says of n factorial is equals to n minus 1, just like the example. Thank you. Okay, now let's move on to the little support. Let's solve simple factorial. But wait, number 1, 6 factorial, 2, 4 factorial, 3, 9, 2 factorial. Okay, now let's start answering. In 6 factorial, we have 6 times 5 times 4 times 3 times 2 and times 1. Solve it using by your calculator, and your answer is 720. 6 factorial is equals to 720. Next is 4 factorial is equals to 4 times 3 times 2 and times 1 is equals to 24. 4 factorial is equals to 24. And now, in third one is 9 minus 2 it equals to 7 factorial. And then, the next is 7 factorial is equals to 7 times 6 times 5 times 4 times 3 times 2 and times 1. And the answer of 7 factorial is 1,040. And then, these are the simplest form or simple solving in combinatorics. Combinatorics can help us count. Combinatorics can help us count in order or than in the number order in which can something happen. Something happen. And that's it. And that's the basic solving in combinatorics in simply factorial. And now let's move on to the real life application application of combination and permutation. So, this is a simple situational. So, my mother, sister, and I went to the mall to buy new clothes. After a few minutes, our mother chose 3 clothes for us. And then the 3 clothes have 3 colors. They are red, blue, and green. So, the question is, how many different combination and permutation that you think you can choose on these 3 colors? So, the combination are the red, blue, and green. So, three combination, the way of arranging. And the permutation, they have 6 possible outcomes. They like the red, blue, and green. The blue, green, red, and then green, blue, and red. And the remaining 3 of these is the shuffle of these 3 colors. So the answer of all is, the combination is 3, and the rearrangement of the arrangement in 3 colors, and the permutation is 6 possibly outcomes when choosing clothes. Remember, in combinatorics has many application in area of mathematics or area of math, including like graph theory, coding or codes, cryptography, and probability. And when we say cryptography, it is a method or process of protecting information and communication through the use of code, so that for those whom intended for information can read and process. And the word cryptography, and the prefix of crypto, means hidden or vault. And the word graphy in suffix stands for writing. And now let's move on to the real-life application. Real-life application of permutation and combination example. And by the way, Permutation is refers to the way of arrangement of a specific order of an object. And now let's back to the example. You are to set 3 digits in combination or permutation lock with each with 3 rotating wheels with each 10 different numbers. So, the answer is obtained by P 10 3 inside the parentheses, and we can read as the number of permutation is the number of permutation of 10 digits taken 3 at a time. So, the answer is 720 ways or possible outcomes to set codes in permutation or combination lock. And before we end our lesson, we need to take some summary. And now let's take our short summary about combinatorics. Okay. When we say combination, it is a mathematical or math technique that determines the arrangement of collection of items or items which the order of the selection does. And then while permutation is arrangement or listing object in which the order is important. So, take our formula of these two in combination. The formula of that is just like this. So, this one we can read as the number of combination. This one can be called as the number of objects, and our factorial is the number of choosing objects from a set. And then in permutation, just simply of this, and we can read as the number of permutation is taken by R at a time. And that's it. And I hope you learned in my presentation and you learn a lot. And thank you for listening and watching from my presentation. I hope you like it, and that's all, and goodbye. See ya!